Picture walking into a modern factory where machines monitor themselves, adjust operations automatically, and alert engineers only when intervention is required. Or imagine a greenhouse where soil moisture sensors trigger pumps precisely when needed, optimizing water use without constant human oversight. This is the essence of IoT: connecting devices, sensors, and systems so they can collect, process, and act on data efficiently. In this lesson, we'll break down how IoT works in practice, why understanding each layer, from sensors to networks to cloud platforms, is critical, and how devices like the ESP32 let you implement these systems hands-on. By the end, you'll know how to identify IoT applications, understand their components, and approach projects with practical, real-world problem-solving strategies. Every IoT system functions as a chain where sensors sense, devices process, and networks relay information for action. Think of a temperature sensor in a greenhouse. Reading the value alone is meaningless unless it triggers a fan or irrigation pump. Networks like Wi-Fi, BLE, or MQTT are the nervous system, connecting devices locally or to cloud dashboards. When I first built a distributed sensor network, I realized latency and reliability mattered more than raw data. Knowing where to process locally versus sending data to the cloud saved me countless debugging hours. Reflect. Where in your design does speed matter, and where can decisions be centralized? Visualizing IoT as a four-step chain, sense, transmit, process, act, helps you plan robust, actionable systems from the outset. IoT isn't abstract. It solves tangible problems across sectors. In manufacturing, vibration sensors prevent motor failures through predictive maintenance. Agriculture relies on soil and climate sensors for precise irrigation. Smart homes adjust lights, temperature, and security automatically. Healthcare wearables monitor vitals, sending alerts for anomalies. Logistics companies track fleet and assets via GPS sensors. When I implemented an industrial sensor network, understanding which protocol and sensor type suited the environment was critical. A wrong choice could cost weeks of recalibration. Ask yourself, what problem am I solving, and which sensors, networks, and control strategies make it efficient? Recognizing patterns across applications helps adapt your design to new contexts quickly. IoT can be broken into three key pillars: devices, networks, and platforms. Devices include ESP32 boards, sensors, and actuators that interact with the physical world. Networks like Wi-Fi, BLE, or LoRa ensure reliable data transmission. Platforms, whether cloud-based or local dashboards, process and visualize data, turning raw numbers into actionable insights. When I built a multi-sensor environmental monitor, selecting the right combination of devices and networks was critical to meet latency, reliability, and security requirements. Visual diagrams help identify how each component interacts and highlight potential bottlenecks. By experimenting with ESP32-based projects, you'll see firsthand how the pillars integrate and why thoughtful architecture matters for troubleshooting and optimization. Data without decisions is just noise. In IoT, sensors feed information to controllers or cloud platforms, which then trigger actions, like switching a fan on or sending an alert. In an industrial motor monitoring setup I worked on, vibration sensors send data to an ESP32 hub. The system decided whether to alert engineers or shut down the motor instantly. Local processing reduces latency, but cloud integration enables analytics and logging. Ask yourself, which decisions require immediate local response and which can be deferred to the cloud? Mapping data flow from sensors through processing to actuators clarifies system design, reveals potential failure points, and ensures reliable operation under real-world conditions. Hands-on experimentation reinforces these insights faster than theory alone. In this lesson, you explored what IoT is, why it matters, and how devices, networks, and platforms connect to create actionable systems. You examined real-world applications in manufacturing, agriculture, healthcare, and smart homes, and learned how ESP32 boards facilitate hands-on experimentation. By visualizing data flow, decision-making, and component interactions, you now have a framework for designing, troubleshooting, and implementing IoT solutions. Each small project you build reinforces these concepts and prepares you to tackle more complex automation challenges with confidence.